Hello and welcome to the Monday lecture for Algebra 1 Part 1. Today we're looking at doing a quick little review for a test that we're going to have tomorrow, which is mainly going to be on standard form, a little bit of graphing work. Okay, so let's jump right into things. So in graphing in standard form, we talked about one way to make it happen and to make it somewhat manageable. We talked about what was called the cover-up method. And in the cover-up method, we're going to cover up one of the variables and solve for the other variable. When we do that in this one, it's actually not that bad, and I'm going to make this graph a little bit smaller because it's kind of large and in charge right now. And I'd like to be able to see it a little bit better. So let's put that right there and call that good. So graphing in standard form, we cover up one of the variables and solve for the other one. And really what I'm doing there is I'm covering up that variable and then rewriting what I have. So this tells me y equals -3. I don't have to write the plus y out in front because that's a little bit overkill. But it tells me that y equals -3. That's going to be my y-intercept at -3. Now, I've talked about a bunch of ways that you can sort of cover up a variable without having to actually cross it out. I've talked about there's times that I just cover it up with my pen. If I'm looking at it either on a computer screen or on a piece of paper, I might just cover it up with my hand, but that looks weird because I'm writing over here. You see me over here, so I kind of like cover it up. Looks like I'm waiting for a high five that I never get unless I give it to myself. All right. So I cover up that other one, and you've seen me do this multiple times where I use a little magic cover-up square. That makes it look really nice, except for that weird space in between. So I do rewrite it every time. And in this case, I get x equals -3. So I get this one right here. So now with those 2 points, that's enough to graph my line. And I'll graph it both ways, just to where we can, and I missed that one a little bit, see where it really goes. I don't just want to see what happens in between these 2 points. I want to predict the future and know the past all at the same time. Okay, so that's the graph that I get for this equation. Now I do want to look at something a little bit different. Let's say I change this. And this is actually on the next slide, but I want to put it on the same one. So I'm going to change this to a minus sign there. Now what do you think is the difference? Without actually doing it, what do you think that's going to change? And whenever I ask that question, I get a lot of differing answers. And all of them kind of revolve around the same idea. Well, it probably flips, right? That line's probably going to flip somehow. But it's actually tricky about where it flips and sort of in what way that it flips, to be honest. So I would always just recommend, well, just do the problem again. Treat that as a whole new problem. But we can gain some insight about what changes and how that affects the rest of the problem. So if I look at this and I use my cover up, let me bring that back in front. If I cover up the x, I'm left with -y equals -3. Whereas before I just had y equals -3. Now I have -y equals -3. And when I solve that, I end up with y equals +3. Okay, so this point actually moved to right there. And that's interesting. But let's see what else happens. When I cover up the y, I get that x still equals -3. So that point actually stays put. So it's almost like I've moved this point here and kept this point the same. And my new line, let me throw a little bit of color out there. My new line comes right through there. So it's actually not so much a flip as it looks like it's a rotation, right? I stuck that point there and I rotated my line a little ways, okay? So that's kind of interesting and really what that means, okay? What that actually did when I changed the left side of this equation, it does keep some things the same, it does change other things. And more interestingly, I would say that it changes the slope of my line. If we look at the first one that we graphed in black, it has a slope of, well, it went from here to here. So kind of like down 3 and over 3, which as a slope, that means negative 3 over 3, which is the same as negative 1. And if I look at my blue line, it goes from here to here. So it kind of goes up 3 and over 3, which on that one is a slope of 1. Sorry about that. So that one has a slope of 1, whereas this one had a slope of negative 1. So adding that negative in between the x and the y flipped my slope over, which is weird. Okay. Now, that really kind of hurts, I would say. More than anything, that hurts. Because it changed it so much. It changed my slope around. It left one of the intercepts the same. It changed the other one. There's really not a great way to look at doing this, right? There's not like a quick way to say how these two lines are similar, different. You know, can I just graph one from the other one? It really kind of forces us to redo the problem, which I hate it when that's the case, but that's kind of the best way. Okay. But it is interesting that there are similarities, there are differences, and and it's not really that clear as to what the similarities and differences are. Okay. What is interesting to look at is, let's say that we take this same line, or this same equation, and we change something else. Let's change that. Instead of x plus y equals negative 3, let's make that a positive 3. Now, what does that change? What do you think that's going to change from this one? And maybe you're on the right track, and maybe you just went ahead and did the problem, which is still probably what I would have done. And it's still probably the easiest way to look at it. One thing that we should kind of believe is that since going from this one to this one changed my slope, sort of flipped my slope around, I might believe that this line and this new line have the same slope. And it turns out that they will. Okay? But let's go ahead and do the problem and see what we come up with. If I cover up the x, I get that y equals positive 3. So I actually get a repeated y-intercept of positive 3 that I had from my blue line. So that's not really anything to do with this black line, but I get the same y-intercept again. What about an x-intercept? If I cover up the y, I get that x equals 3. Oops, I was doing my x-intercepts in green. I'll continue that. And so I get that one. So on this one, if we take away the blue line, because we're not really trying to look at anything to do with the blue line, and I'm even going to get rid of all that stuff too. Maybe. Delete. There we go. Don't want any of that. Okay. So on this one, it sort of moved my y-intercept up, and for my x-intercept, it moved it over here. So they kind of crossed, kind of some weird stuff happened. But I get a new line through these points. And how do these lines compare? And why do you think that is? Well, it turns out that these two lines actually have the same slope, and they kind of look parallel. If I were to graph them precisely, they would look more parallel. I would say that they're a little bit closer down here. One of them's off a little bit, but we can accept that. These are parallel lines. They're never going to cross. They have the same slope. Okay, and we're going to get into this a little bit later, but it turns out that in standard form, and I've mentioned this before, that standard form is written as capital AX plus capital BY equals C. It turns out that the slope in standard form is related to these A's and B's. Okay? And I guess technically the slope is, let me make sure I do it right. That over divide is negative A over B. So that's a little bit advanced, but you could use that if you ever needed to. But that is interesting, that's what the slope comes from. And that's why these two have the same slope, because their left sides look the same. It's just kind of cool. All right, let's look at another one. So I've skipped ahead a little bit. That last one was just one that we've already done before, or that we just did. Looking at this one, I have 10x minus 20y equals 40. And we mentioned that we really like to use the cover-up method. This one is no exception. I really would like to use the cover-up method. Because even though I have some big numbers here, when I cover up the x, I get negative 20y equals 40. And when I divide both sides by negative 20 to solve for y, 40 over negative 20 is just negative 2. So I get a y-intercept at negative 2. When I go back through on the problem and I cover up the x, I knew that was there somewhere. And I cover up the x, even though, again, I have some bigger numbers, I have 10x is equal to 40. If I divide both sides by 10, I get that x is equal to 4. So the x-intercept is 4. And I can graph my line. I have my 2 points. That's all I ever need. And that misses that point a little bit. I'll try to fix that somewhere in there. It's a little bit too high, but it goes right there. Let's test my theory a little bit. Because whenever you come up with an idea, you should always check it. See if it works out or if it falls apart. If I look at the slope of this, I notice it goes up 1, 2, and over 1, 2, 3, 4. It goes up 2 and over 4. And if I write that as a slope, 2 over 4, I'm going to get a slope of up 1 over 2. Again, let's test my theory a little bit. Oops. And I mentioned that the slope comes from the opposite of A divided by B. Oops, not this. So if I look at this, and I say that it's the opposite of A over B, well, this one's A and this one's B, the The opposite of A, the opposite of 10 is negative 10. And B is not just 20, it includes that sign, it's negative 20. And negative 10 divided by negative 20 is going to just be 1/2 or 0.5, which is the same thing that we get right here. So it does work out. Now again, that's just kind of an advanced tool. You don't need to use that. As long as you can do the cover-up method, you can definitely graph your line. It's just kind of cool that you could figure out what your slope is ahead of time. And sometimes it's not that hard. Let's look at another one. What's different here? What stands out to you on this problem? Let's pretend like nothing stands out to us because we're not shocked by anything that Mr. Gall can throw at us. And let's cover up. Not only are we not shocked, but we're also not amused. We're on to your business. I get 2y equals 0. Well, that seems a little bit odd. But when I divide by 2, I get y equals 0. So that's an interesting y-intercept for one reason. Do you see it yet? Maybe you don't. Let's see if this will help. What is my x-intercept? It's supposed to be a 0. Divide both sides by 3, and maybe you see it now. The x-intercept is also 0. So this gives us some troubles. What line do I graph? So it turns out that when you have a standard form graph that is equal to 0, you're gonna have some issues. Because I only have one point. I kind of graphed the same point twice. Does that mean that it's just that point? It doesn't move? And it turns out, no, that's not the case either. Okay, it has to move a little bit. Okay, it has to move a lot, really. It's a line. I still need to graph a line. So what line do I graph? You know, some initial guesses turn out to be this or this. Come here. Those are some initial guesses, and sadly, they're both incorrect. Okay, that's not actually the case. So what do? Well, if we paid attention in the last 10 minutes, we might have an idea. And that is one thing we can do, is that we can find our slope from our opposite of A over B. That's kind of tricky because, again, that's kind of an advanced strategy. There's another thing that I can do. It's kind of the first thing we did when we ever graphed. We can make a table of values. And we already know one result. I know that if I plug in 0 for x, I'm going to get 0 for y. That's why this point's on there. So then what do? Well, then we just pick another value, and it can be anything. Right? Anything that we want to think of. It can be 1. 1 would work. Let me give you a little hint. It's not going to end up in anything that's really pretty, but it still works. 3 times 1 is 3. Okay, my pen's lagging. Not happy. It's lagging a lot. I'm really not happy. I'm not doing anything, and it's moving. Let me try this. Plus 2y is equal to 0. Let's see if it'll work again. Okay, it's kind of working. While it's kind of working, we're going to move fast. So I get 2y is equal to negative 3. I apologize for that. It does happen sometimes. It gets thinking too much. Whenever we think too much, we're in for some issues. So then when I divide by 2, I get y equals negative 3/2, which if you do that on a calculator, it's negative 1.5. which no matter what, it'll work out. It's not great. I hate graphing decimals when my graph doesn't have decimals. But I know that at 1, it's 1.5. Now, I will usually use a trick here. If at 1, it's negative 1.5, then at 2, it's got to be double that. At 2, it's got to be 3. And I know that point. I know where that point is on my graph. So I'm actually going to use those. Notice I didn't really do any more work there. I just doubled, right? And you can always do that. If at negative 1, it's a decimal, well, if it's 0.5, it's got to work out at 2, right? It's got to be negative 3. So that's just kind of an inside trick that I like to use. That makes life a little bit nicer. We get this line. And we get this line right here. And that's just what we have to do. If we come up to a problem in standard form that has a y-intercept, that has a y-intercept or an x-intercept at 0, if one of them's 0, they're both 0, which means we only get 1 point. We have to use the table of values. Or do we? We talked about another way. If I have ax plus by equals 0, or anything, I guess I didn't even have to put 0 there. Could be anything. My slope is always the opposite of a over b. And in this one, I have the slope is negative 3 over 2. Well, I came into that negative 3 over 2 at one point, and I actually used that negative 3 over 2. I started at this point, and I went down 3 and over 2, and it ended me right there. So that's another way that you can do that. If you remember that. Keep in mind, I had to think a little bit on how to come up with that negative a over b. I know that it's a rule, but I don't always remember that rule. When in doubt, use the table of values, come up with another point, and you'd be good to go. All right? Let's look at one last example to get us ready for the test tomorrow. Kind of 2 examples. If I have the line x equals 10, what does that mean? It means put a point at 10 and all other points that have x values at 10. X equals is always going to be a vertical line. Always going to be a vertical line. So we get this one. Goes through x equals 10. Okay. For my other one, y equals negative 6 is always going to be not a vertical line. That one's always going to be a horizontal line. Okay. At y equals negative 6. I don't want a line yet. Negative 6, and all other points that have a y value of negative 6. That happens here, even way back here. All those points have y values at negative 6. And everything in between. So if you can keep it straight in your head that x is a horizontal line and y is a x is a vertical line and y is a horizontal line, do that. If not, say it to yourself. X values at 10, y values at negative 6. That's going to lead you to those horizontal and vertical lines. That being said, I hope you have a great day, and we will see you in class.